Good morning, guys. I will be using this as my example for our solving linear and quadratic systems by graphing. As a graph in your calculator, if you go to Menu, then Graph Entry and Edit and Relation, then you can change your input to a relation. That will allow us to type in our lines the way they are written without having to solve for y and enter it as a function. Here I have graphed the first equation in the calculator, and I will be using Menu, View, Grid, Line to Grid in order to add lines to this graph so I can graph a more accurate line. Normally, I would like to use Control and T to see a table, but because this is as a relation instead of a function, the table will not be populated in the calculator. So estimating off of the grid, I'm now going to be using the points -5, -3, and -2, -5 to graph my line. If you press Tab on your calculator, then it will open up our entry window where we can enter another relation for a second equation. And so here's what it looks like as I add my second equation. I have now graphed that second line by picking points that look like they are clear points the line is going through on the graph. And my second instruction for this first part is to label my solution. That is going to be where these two lines intersect. So the answer to the system is going to be at -2, -5, where these two intersect. Please remember that we count our x coordinates first and our y coordinates second. That means you will be counting to the left and right first and up and down second. So in other words, this point -2, -5 is the solution because that is where our lines intersect. That means that my equation on the left is the same as the equation on my right. I am kind of abusing the equal sign in the middle there to say that this equation is the same as this other equation. That's not technically true, but yeah, again, abusing that equal sign. And then that also means that my x is -2 and y is -5. Please keep in mind that the coordinates of that point are in order. So my first coordinate is x and my second coordinate is y. As for the explanation on how to solve this, you have several options. The easiest would be to say something along the lines of graph the lines and find their intersection. And then you can also mention specific calculator commands to help you get there. To begin my next problem, I will remember I can press delete 3 times to clear out my current graph. So, yes. And because this equation is written as y equals, I'm actually going to change my graph input back to functions. It's a little bit more friendly with the calculator, and I can get some better numbers that way. So to do that, I will press Menu, Graph Entry, and this time I will be selecting 1 for function. And I will enter in each of my 2 equations. The top one will graph as a parabola, the second one will graph as a line. And so I get an equation, or a pair of equations that looks something like this. I will then either use the table as Control-T, or again, just eyeball good points off of my graph, in order to connect the dots and transfer these graphs accurately onto my paper. To graph parabolas, it's usually easiest to draw a couple of dots, 3 to 5, and start at the vertex while drawing each part. To draw lines, of course, we just connect dots in a straight line. Now my problem says to label these solutions. In this case, there are more than one intersection between this line and this parabola. There is one clearly visible on the graph at -2, -2, and I suspect there is another one just off the graph, and so I'll have to use the calculator to help me identify that one. So under Menu and Analyze Graph, we can find an intersection. This will begin by bringing up a line in my graph, in which case I will press Enter to stop that line and start a region where I can select for this graph to look for the intersection. The easiest way to select this is going to be to lightly drag your finger across the touchpad, kind of like a mouse pad on a laptop, to help you widen this gap to the left and right for the calculator to find the intersection. After I pressed Enter, it automatically zoomed me out slightly so I can see where this intersection is, and has labeled it as 2, -10. If that is too much of a jumble for you, you may long press on one of the labels to drag that label out of the way. that would look sort of like this. So even though it is off of my graph, I am going to label that the solution is at 2, -10, headed down in that direction. And that gives me all of my part A and all of the information I need to fill in parts B, C, and D. So then I know the solutions to this system are at -2, -2, where the first intersection was, and 2, -10, where the second intersection is. Because the graph of the line y equals -2x minus 6 and the parabola y equals -x squared minus 2x minus 2 intersect at those 2 points. For filling in those 2 blanks, keep in mind the y equation for the line will not have any powers. It will only have a single x, while parabolas are all characterized by having an x squared. So I know my line has no x squared, and my parabola has an x squared. And again, the general idea of this is we're looking for where these 2 things intersect. I am again abusing that equal sign. It's again not technically equal, but it does mean equivalent. So the line and the parabola are equivalent. They are the same when x is -2 and y is -2, and also when x is 2 and y is -10. So those 2 coordinates, again, x coordinate first, y coordinate second, do make the 2 solutions to this system. As far as explaining this system, you can again say something similar to the answers to problem 1 by writing that we are going to graph the equation of the line and the parabola to find where they intersect. And again, I would like some more detail in this writing, such as which steps you use in the calculator, or which buttons you use in the calculator to get there. As a final note, keep in mind that problem 3's part D is not the same as problem 2's part D, and that in this case I'm looking for a picture of a linear and quadratic function, so a line and a parabola that has no solution. Keep in mind, solutions are found where the line and the parabola intersect, and try and use that information in order to draw this picture. The goal for today's work is to understand the relationships between graphs and systems of equations, namely that we can solve systems of equations, these things that have more than one variable and more than one equation, by finding where they intersect if we can graph them. So for our simple problems that have just an x and a y, these are fairly easy to graph and find their intersections. As an additional note, all of the answers to your worksheet are designed to be nice. You should not be ending up with decimals or approximations. Most likely, if that's what the calculator is telling you, most likely you have to work on which negative sign to use. Make sure you're using the correct subtract instead of negative as you enter these into the calculator. Thanks. I hope you have a wonderful day.